So more 10.3 notes. We were talking about ellipses, and we said at the end of the last video that we would FOIL it out to get the general form and complete the square twice to get to standard form. I want to point out one thing about the general form for an ellipse. Remember, for a circle, when you were in the general form, the x squared and the y squared were both positive, and they had the same coefficient. For an ellipse, it's going to be a little bit different. On an ellipse, the x squared and y squared are still both going to be positive, but they have different coefficients. The reason they're going to have different coefficients is because it's sort of like they have a different radius. That semi-minor axis and the semi-major axis are different numbers, so it's going to cause us to have different coefficients when we FOIL everything out. Let's jump right into an example of this, where we're taking an equation of 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. We're going to try to put it into that other form, where we complete the square twice, and then find all of the important parts about the ellipse. This is a very representative question of what you will see on the test. We'll start this the same way we start circles. We're going to start by putting the x's together, leave a space, put the y's together, leave a space, and move the constant term to the other side. I should point out that we know that this original equation here is an ellipse because the x squared and the y squared are both positive and they have different coefficients. So that's how you could tell from the beginning that this is an ellipse. Now it's important to note, before you complete the square, you have to factor. What that means is we need to factor this 4 out of the x term and factor the 9 out of the y term. So now we can complete the square. Remember, we cut this middle number in half, and then we square it. So negative 10 cut in half is 5. 5 squared is 25. But when you add it to the other side, we are not going to add 25 to the other side. We need to add 4 times 25 to the other side. We need to add 100 to the other side. Let's complete the square the same way on the y's. Take the middle number, cut it in half, and square it. We're going to add 4 to complete the square. But that's really going to be a 36 when you add it to the other side. So let's see what we get here. We get 4 times, and then what is that if it factors out into a perfect square? X minus 5, x minus 5. So x minus 5 squared. And 9 times, factor out the y's into y plus 2 squared. And on the other side, if we do negative 100 plus 100 plus 36, we get 36. This is very close to the form that we want it in, but in the form that we want it in, it should equal 1. So to make it equal 1, we need to just divide everything on both sides by 36. And as we divide here, we'll put the fraction in lowest terms. 4 over 36 is like 1 over 9. So we get x minus 5 squared over 9. Same thing with the coefficients here. 9 over 36 is 1 over 4. So y plus 2 squared over 4. And then it equals 1. This is the form we want the ellipse in, so that we can find out where's the center, where are the vertices, where are the foci, and make a graph of it. Pause the video for a moment and see if you can, on your own, figure out where's the center, where are the vertices, where are the foci, and make a quick graph of it. You might want to graph it from the beginning. And then start the video when you're ready to figure out if you were right or not. Center's at 5, -2. Vertices are at 2, -2, 8, -2, 5, 0, 5, -4. Foci are at 5 plus or minus the square root of 5, comma, -2. Just a quick rundown of how we got those. For the center, I was looking inside the parentheses here, so that's why I got the 5, -2 for the center. To figure out the vertices, in the x direction, I needed to move 3. Oops. X direction, move 3. So I added and subtracted 3 to the x number to get the new x numbers in the vertices. And then I did the same thing in the y direction. In the y direction, I needed to go 2. So I added and subtracted 2 from the y number to get the vertices. For the c value, I used the equation to figure out c is the square root of 5. Since the x number is bigger, I am adding and subtracting that c value to the x from the center. In the graph of it, you'll notice that this ellipse looks pretty much like a circle. Sometimes the ellipses are going to look like a circle, mostly like a circle, and that's when the minor axis and the major axis are pretty much the same number. But sometimes it's going to look really not like a circle. It's going to be really oblong when the semi-major axis and the semi-minor axis are very, very different. We have a word for that. It's called the eccentricity of an ellipse. The eccentricity is a measure of how ellipsy the ellipse is. It's just a number. It's a number that ranks the ellipses. So if you had a picture of every ellipse in the world, each ellipse would be assigned a number. It's kind of like a ranking system, 1 to 10. Except for it's not 1 to 10, it's 0 to 1. If the ellipse gets a rank that's close to 0, that means it pretty much looks like a circle. If the ellipse gets a number that's close to 1, that means it's very, very oblong. It's almost like a straight line. It's very, very stretched out. That e value isn't just a random number that someone is assigning to it arbitrarily. The e number is exactly equal to c over a. C and a mean the same things that they meant before. C is still the distance from the center to the foci. A is still the length of the semi-major axis. So we might have an example where they give us the eccentricity and we have to figure some things out using that. So I'm going to do some examples here. Let's do this one first and then we'll come back to that other one. The center of an ellipse is 3, 1. The vertical semi-major axis is 6 units long, and E is 1/3. Let's write an equation for that ellipse. There's a lot of information in here. The big thing that I'm going to point out first is that it has a vertical semi-major axis. Vertical means up and down. So in this ellipse, the A number is going to go underneath the Y's and not underneath the X's. Now I can fill in a few other things. I know where the center is. And I also know that the semi-major axis is 6 units long. Semi-major axis, that's just A. So A is 6 units long. So I can fill in a 36 underneath the Y's. But now we get into what's B. Here's where we're going to use the eccentricity. The eccentricity of this ellipse is 1/3. We have a formula that says E equals C over A. So 1/3 equals C over A. That does not mean that the C is exactly 1 and the A is exactly 3. It just means they're in that ratio 1:3. And in fact, in this case, I know for sure that it's not 1 and 3 because A is 6. So if they need to be in that 1:3 ratio and A is 6, C has to be 2. This is one where you can kind of figure that out using mental math. If you didn't have a situation where you could figure it out using mental math, you can always cross multiply to solve the proportion and get 6 equals 3C, and then you still end up with C equals 2. That's how you might want to do it if the numbers were a little bit tougher. But that's C, so C is not the number that's going to go in the equation. We still need to figure out B. Well, we have another equation that relates A's, B's, and C's. A squared minus B squared equals C squared. We know that A squared is 36. We know that C is 2, so C squared would be 4. And we can figure out B squared. Now you'll notice I stopped short of figuring out what B is because for the equation, I don't really need to know what B is. In the equation, it's B squared anyway. So just put that 32 in underneath the X. Now you have your value for B squared, and that fills in the whole equation. One last example, writing an equation for an ellipse based on some information that they give you. Again, the last example and this one too are representative of what you're going to see on the test. There'll be some questions where I give you an equation and ask you to graph it and find all the important stuff. Some questions where I give you a graph and ask you to come up with an equation. And then the third type are like these last two, where I give you a description of it and ask you to write the equation. This one seems almost like they don't give us enough information, but really they do once you start breaking it down. The foci are at -1, 0, and +1, 0. So really, we should know where the center is. The center is going to be halfway in between those two, so you can use the midpoint formula from 10(1), or just know that the midpoint there is going to be 0, 0. When it is 0, 0, you don't need to write x minus 0 squared. You can just write x squared, and that's fine. Now they gave us a for that equation, which is great. We just need to figure out where is the a going to go. Is it going to go underneath the x's, or underneath the y's. Since the foci are left and right from each other, that means this is going to be a horizontal ellipse. So the bigger number is in the x direction, so the A is going to go in the x direction. Sort of like that last example, the only thing that's left is I need to figure out what b squared is. I know A, and it would really help if I either knew the eccentricity, which I don't know, or if I knew C, and there is a way for us to find C. Well, what does C mean? C is the distance from the center to a focus. And I always remember that because those two words have C's in them. I know how far it is from the center to a focus. It's 1. So now I've got C, I had A from the beginning. I can use that other equation, a squared minus b squared equals c squared, and figure out what b is to put in the equation. Those are all the examples that we have to do about ellipses. You have some homework where you can practice doing those things on your own. And I'll remind you again of the different types of things that you should be able to do. You should be able to, given an equation, make a graph and find the important stuff. Important stuff are vertices, foci, center, eccentricity. You should be able to find all of those things. You should be able to, given a graph, write the equation. You should be able to, given a description like the last one, write an equation. And given an equation in that general form, you should be able to complete the square twice and graph and find the important stuff. Those things are going to be consistent throughout all of our conic sections. You should be able to do that for circles and ellipses so far. Then in the next 2 sections, you'll learn how to do that for hyperbolas and for parabolas. For every conic section we do, you should be able to do those 4 things. Take the rest of the time now to work on that homework assignment, and then we will go over it when I see you again on Monday.